Raise your hand. No one? Okay, so yes, thank you. Yeah, I wanted to share with you because I found that this program is very convenient. For example, for listing of files, we could sort it, view it, sort by name, ascending or descending order, or extension, size, date, for example. So in order to find some things, it's very convenient. For example, in this case, I wanted to delete files. Select it and delete. It's very convenient. And today we learn about the data representation, how our data, our information are stored inside our computer. Different type, we have different type of information, right? And also about the file structures. And do you have any questions so far concerning about the operating system, about the computer architecture, concerning about the software tools? Any question? No? So today we learn about the data representation and file structures. You have already practiced for we have uploaded the practice into the model system, and you could practice with operating system and software. And today we learn about the data representation software. We practice with how to make the text files into different approaches. First one is what you see is what you get. You use Microsoft Word, OpenOffice to create your documents or your HTML files using text, different kind of markup language. And I have presented you the data information, knowledge and wisdom pyramid. Everything stored in our computer are numbers, just 0 and 1. And just our files, just a list or an array of or arrangement of symbols. And the symbols here are all the numbers 0 and 1. And if we are given some context information about the data or information about the data, we have the data. Now we learn about how we create the data and how we manage the data to have the information. We have talked about the analog to digital conversions because we want to digitize all the signals of our outside world and to store, to process by using our computer. We need to connect the signals from an analog world into number into a finite number, like this one. For example, with the microphone here, my speech, my wave, sound wave, are decoded by some electrical sensors. And after that, it converts into, usually I think that is digital. It converted into the digital number. Here, it transmit to amplifier, and the amplifier transmit to convert back the digital signal into the wavelet so that our speaker created again, recreate the wavelet, and so that we have sound inside our classroom. fact, we live in a children's world of sensors. And we have different types of sensors, including capturing the light signal, the humidity, the temperature, acoustic or sound vibrations, and radio sensors in different, for different applications. And I would like to take this example of how our camera, digital camera, takes the pictures, how our smartphone takes the pictures. Here, the first part, we have, the outside object, the real world object. And the light goes through a set of lenses. We have different types of lenses. If you are a photographer, we could see that we have different camera body produced by Canon, Sony, etc. And also, there are some companies that just produce the lens. And you could see that for some kind of lens, they are very, very expensive. Some lenses are designed for specific purposes. For example, you could see the journalists use the camera in the stadium. Yes, very long, very big lens. And on our cameras, we have also very small lens like this one. And in principle, they are the same. They direct the light into the light sensor. And if you are in physics or in chemistry, you will learn how to design or develop such kind of sensor. Capture the strength of the light signals. And actually, in our normal digital cameras, we have the so-called color filter arrays to capture the strength signal of the red, of the green, and blue colors. So, because the set of the wavelength is smooth, so we need an analog electronic this to capture the strength of the signals. And after that, we need an analog to digital converters to convert the curved signal into the discretized signal. And different company, big company, produce different type of the sensors. And different cameras or smartphone company develop different digital image processing AI camera. They are here. They develop different algorithms to process the image before it is saved into our hard disk, or in this case, as it is usually. And because we could see that the principle are the same, but different type of lens, different type of sensor, different type of image processing produce different color, different quality or property of the pictures. You could say that, for example, for the iPhone, for the Samsung phone, the picture taken by different cameras are different because they are different in length, in the sensor, the size of sensor, and different algorithms. And sometimes, the camera companies compete to each other by developing its specific algorithms for processing this. And we also hear about the optical zoom and the digital zoom. We could see the term optical stabilization and digital stabilization. Who knows what are the difference between the optical zoom and the digital zoom? Who are the cameramen know about the digital zoom and optical zoom? Very big, yeah. Very basic concept in photography. Who knows the difference between the optical zoom and the digital zoom? Who knows? Share, yeah, just share with us. Please share with us.
I think optical zoom is like you change the lens to zoom out the picture, and digital is like you zoom in you use program to zoom out the existing image.
Yeah, thank you. Yeah, that's basically. Yes, thank you very much. And that's very basic concept, right, in cameras. But not all of you know about that. Not everyone know about that. Yeah, he said that. Thank you very much for your sharing. That's exactly what you said. When we talk about the optical zoom, it means that it's 2 times, 4 times, larger, or focus more, or zoom in or views the object in a larger views. For example, we adjust the lens system here. Sometimes you could see there the photographer rotate. Some they can in the path here it moves. Adjust. But that's for the adjustable lens. And in our smartphone here, sometimes we have 2 times, 4 times, even 12 times larger. And usually, the algorithm is applied here. We could see that. Let's imagine our television set has 4K resolution. But what happens if our picture is just HD or 2K? So, for example, for Sony, they develop algorithms and implemented in the graphical processing unit and to enlarge. For example, if the original picture is just, for example, HD, they try to enlarge the pictures into 4K, for example. And we still see very smoothly the pictures. Not like in the previous picture, I saw that. With the mid-map phones, if we enlarge the size of the phone, we see that the quality of the picture is great. So, it means that in order to convert our signals from the analog world, our current living world here, into the digital signals, there are so many steps. And people design the step in order to capture the information from the outside world into the digital world as good as possible, as correct as possible. Of course, no free lunch. If we try to, this very expensive if we design a very large room here, but for algorithms, sometimes it's much more cheaper. Of course, the quality of the picture is not so as good as we have very good lens. That's the common principle for converting our analog, our world into the digital world. And I also use this example to illustrate about you how our color, the pixels, the color of the pixel are combination of three numbers. Now, I would like to show you an examples and about text file. Now I would like to take to make a text I save it. You do, yeah, you do it every day. So, the first file I save in the SF, the name lch.txt. I save it in another format. The default format or default encoding scheme is UTF-8. Now I try with another encoding scheme. Now USDH with the ANSI. With the same content. I save it to another file. With the encoding is UTF-16. You see that? Yeah. With the same content as 4 characters. Now, USDH, and USDH. So 3 files have the same content. 1, 2, and 3. The 3 files have the identical content, but you will see that the first file has a size of 4 bytes. The second one, 4 bytes. The third one requires 10 bytes. That's the first example. Now, I would like to take another example. I type it in Vietnamese. Another. Yes. I use UTF-8. I save it as UTF-16. When I save this file, contain Vietnamese characters, Vietnamese text in an ANSI format or encoding scheme. It won't. There's warning about this file contains character in Unicode format which will be lost. If you save this files as an ANSI encoder text files. Keep the encoder, something like that, somebody, okay, I try to save it in ANSI anyway. The content, some characters, change. Some characters are the same. And we could see that with three different file formats. The first requires 12, the second requires 20, and the third one requires 9 bytes. I give you two examples, and now we try to understand it, and we try to solve the problem. Now, who has the answer? Who could explain, share your understanding about why? Yes.
Okay, so in my experience, so you type this letter Viet Pháp is in Vietnamese, so this text file do not it's not support. Yeah, it's not support in Vietnamese. So we should change like some question or rectangle.
Just a moment.
Okay.
Yes. Yes. For the first stage, the file contains USDH only.
Yes.
Why the first files require four bytes?
I think the length of the length of
4 bytes. Why is 10?
you type so many words in there, so the length of the file speed
The file has how many characters?
4 letters.
4 letters,
Yes.
4 characters, and it requires 4 bytes.
Yes.
For the ANSI working, 4 bytes. For UTF-16, it's 10 bytes. Why? I guess, yeah.
Yeah, I guess you type inside the file you type much more word than in the USDH ANSI.
The content of USDH is just USDH1.
Okay, so I think in this file,
Just USDH.
yeah, just USDH.
Yes. So it's been I guess. You could guess that 4 bytes for storing 4 characters, right? Yes. Now, okay, I remove this one because it's good. So, for ANSI and USDH, I guess the content of the file is 4 characters, so it requires 1 byte for 1 character, right? For the USDF 16 means 8 by 2. It means that it requires 2 bytes to store 1 character. So we have 4 characters. We have four characters. U, S, D, H. We have 4 characters.
With 4 bytes.
So if you use 1 byte for 1 character, it requires 4 bytes. If we use 2 bytes for 1 character,
Is equal
8 bytes. But why in this case it requires 2 more. 8. Instead of 8, it's 10.
The USGH. Okay, you want to say the difference between the USGH with this and this, 2 of this are different by. Yes.
Now, I guess let's factor the class. Space. How many characters? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 characters. Now, we have the second file, we have 9 characters. For the ANSI, okay, 9 bytes is means that 1 byte for 1 character. But why is it 12? Is UTF-8 and why is it means that 9 if we use UTF-8, so it's means 18. But now it's 20 bytes. It's 20.
Em trả lời bằng tiếng Việt nhé.
No, I express. You understand?
Bởi vì bên trong
No. Try.
I think
Because, yeah.
I think it's like your file have the Vietnamese point and the space and the
In uppercase. Uppercase.
yeah, uppercase. So it's increase the byte.
No, not that. Okay, thank you.
để xin lỗi thầy cho em.
No.
Em số là thầy.
Okay, no, it's okay. Who has an idea? Who has any idea?
I think between IC and UTF-16, the use the encoding of UTF-16 is more complex than IC, so this require more storage to do that.
Yeah.
That's it.
Yeah. He said that the ANSI use simpler scheme to store the information, right? So that's why it said the space. Because you could imagine that this text file will have only 4 characters or 9 characters. But you could see that when we have a huge number of documents, a huge number of web pages, you could imagine the volume is so different. Now, who could explain me why there's something different here? We store the same amount of information, amount of data, but sometimes we require more necessary space. Who could explain? Because today we learned about the data representations and file structures. Yeah, I guess. In fact, it's 10 bytes. Here, in fact, it's 20. So, 8, 10, the similar between the 18 and 20 is mean that it requires 2 more bytes for the Unicode. And for the UTF-8, it's 4 and this requires, in this case, requires just only 3 bytes, 3 more bytes. And I would like to share you here once again Now we inspect. The characters here, the inside of the text file. The most commonly used if we short view it in the USTH. This the UTF-60. Could you see it? Okay. The magnifier is not so good actually, but I have to fix it. Now this is what inside the text file. We inspect we could see that we have the U dot S dot T dot H dot, and the dot here has code 00000000, and actually there are 2 bytes FF and FE. After that 55 in hexagonal is for U. 53 S, 54 is T, and 48 for H. That's the code, the ANSI code for your STH. Now, inspect again with the get file, UFTH. I view it. Option in hexagonal. We also see that, we have found here. D, I, A, T, and B. Here, and the dot is for 00. We also have the first 2 characters to number, FF and FE. FF and FE. You could see the FF and FE for they all have FF and FE. You see? So the reason is for UTF 60 for every text file, the representation, the signature for the every text file stored in Unicode 16 format should start with FF and FE, and this is the rule. Why do we need such kind of rule? It means that for UTF 16, we need 2 more bytes. At the beginning of every text file in UTF 16. You know why? Okay, I take another example. Bitmap is one of the most commonly used format for raster image, and I take these pictures from our homepage several years ago, and I try to save this picture in 2 different formats. The first one, the same bitmap files with 24 bits, and another picture is in 8 bits. which one is in 8 bit and which one is in 24 bits. Could you distinguish it? Which one?
The right is the 24 and the left is the 8.
Yes. So you could see in the quality of the pictures.
Yes.
And yeah, also yes, I saw it in here. The left pictures written here in bitmap use the same format, bitmap format, but I set it in just on the 8 bit. I shut the order. And this one is in 24 bits. 24 bits is mean for each pixel, the files use 3 or 24 bits for store the information about one picture. One picture. And in USD, for 8 bits, it means that 1 byte only for store the pictures. And you push upload for some algorithms, it converts from the 24 bits into 8 bits, and we could see that the quality is still good enough, for example. But in this case, it requires in our memory because the bitmap file image is not compressible. 2 megabytes, 2.6 megabytes, and it's 8 megabytes. We could see that almost 3 times larger. Now, we display again. Now, in this one, I put here, I put demonstrate. For the, I select the USGA. Here. Here. I mark it with I mark 2 files and I use the command compare by content. The function compare by content, highlight every differences among the 2 files. Of course, now we inspect the very beginning of the files. I have prepared this way. Now the first information, the first data beginning at every bitmap file, we found 32, 40, and after that 4 numbers. And also in the Unicode files, we have the signature here. We call for every bitmap image we have the bitmap PMP extension. So that that's the bigger that the computer know that this is the bitmap files. And not only is the name because we could change the name by ourselves, but anyway in the header of the files, we have the 2 numbers, 42 and 40, 42 and 40, and after that is difference. Now, this is the structure of a bitmap file system because today if you do coding, you do programming, and you have to open a bitmap file. In the class myself, we have to read every byte. We have to study about the structure of a bitmap file. And the ISO organizations document that every bitmap file should have this structure. And the first 2 bytes, the left here is 4 bytes. The first 2 bytes is a signature. And every format, bitmap, JPEG, text, and many other for movies, for video, for speech, for text, for image, and any kind of information we have usually, not always. We have the signature byte here. And for bitmap, this is for 2 and 40. And after that, some information about the file size. We know that the next 4 bytes are file size, and so on. The header, deep header, the image size, image width, height in pixels, compression, information, image size is pixel per meter, the resolution, and so on. And at the end of the header is the raw data. That's, for example, for 24 bits, that's 3 bytes. 3 bytes. 3 bytes for the first picture, 3 bytes, next 3 bytes for the second picture. Now, this, I zoom in here. This is a bitmap file header, that's standard. The first 2 bytes is for signature. To identify the bitmap and the device independent bitmap files. This is common for also for printer. The printer knows already about this structure. And the next one is for 2 and 14 because we verify that number. And the next 4 bytes is for the size of the bitmap files. 4 bytes here. 1, 2, 3, 4. 1, 2, 3, 4. 4 bytes are for the size of the files. And we know that the size of the byte here is those numbers. Those numbers are stored in 4 bytes here. Those numbers are stored in 4 bytes. We know that we see the content of the files in the hexagonal numbering system. Now, it's time for us to verify that those numbers are identical, written in 2 different numbering systems. This in hexagonal, actually inside our hard disk in the files. But yeah, those 4 numbers are for representing this number. Now let's talk about the hexagonal. Usually we have the daily line we have from 0 to 9 is in decimal numbering system. In numbering system, decimal numbering system is 8,088,000, 54. In hexagonal is F6, 69, 7B, and 00. That's in hexagonal. And it's 2,697,78 is written in this number in hexagonal. Now, your task is to convert from the hexagonal to decimal number. From hexagonal to decimal, or decimal to hexagonal. Now, we have to verify it. Now, I provide you in our file system, usually this number is written in decimal. 8 million is mean that 8 here means 8 multiplied by 10 power 0. 7 multiplied by 10 power 1. We know that this rule. Now, in hexagonal, you calculate. We could see that F669,7B00, they write the order of the number in the inverse order. So I rearrange this sequence of symbols here into this one. Now using your pen and your paper to verify your understanding about the hexagonal numbering system and the decimal numbering system. And you could explain for every paper here your calculation. Zero, zero, 76, 7B. F 6. In hexagonal, we have 16 numbers from 0, 1, 2, 3, 4, 5. For decimal, we have only 10. But in hexagonal numbering system, we have 0, 1, 2, 10, 9, A for 10, B for 11, C for 12, D for 13, E for 14, and F for 15. Now, using your pen and paper to convert this hexagonal to the decimal. And for decimal writing numbering system, this sequence of symbols means this quantity, this number. Try to explore by yourself. And when people shoot arrows and pencil with paper, try to explain to this kind of numbering system. Now, everyone. Of course, you have my slide ready, so please don't look at my slide, my next slide, because I wanted you discard what is written, what is prepared in my next slide. Okay. Would you read? Yes. But let people think. Yes. Let other people think in some more ways. Of course, with computer, with your calculator, with your smartphone, you can solve the problem very easily. But in order to understand the theory behind the calculation, the principle behind the numbering system, you could explore, because you know that I have prepared a real example about the bitmap files. I take the real number in the bitmap files for you to verify your understanding. Now let's spend 5 minutes for you to do the calculation. Because I wanted you to discover by yourself the meaning of the whole number, meaning of the bitmap files figure. 42, 42, 40 is the signature. The first 2 lines in every bitmap file. You could verify it by yourself. and you discover by yourself the next four numbers, next four bytes in every bit method.
Đây này, mà có cái tác nhân này.
Of course, you could use software to convert the two numbering system. It's too easy for you, but you have to verify it by yourself. Now, who don't know how to convert or who don't know how to compare two numbers, who don't know how to convert from this numbering system to another numbering system, raise your hand. You don't know? Right. So, come here. Okay, because when I know that many of you don't know why the numbering system works. Now this number, you come here, look at very close. You know that this is the number is 8. It means that 8 plus 7 multiplied by 10 is 0, 7,000, right? And so on. You know the rules. You know, this in the decimal. Decimal is mean that 8 is 8, 7 is 7. For the hexagonal, you apply the same rule, right? Starting with from left to right. But in this case, above hexagonal, this in decimal, and this in hexagonal. You start with this number. Now, convert into the, and you know that if we have A, it means 10 in decimal. B, 11, right? You apply the same rule here. Now, click your, here. Okay. Now, you apply the same rule with the hexagonal numbering system. The first number is 6. Okay, plus. Okay, plus. F means 15 multiplied. This is 10 is in decimal. But this numbering system is hexagonal. It means that it's not 10, but it's not 10. But how many? 16, right? Because it's in the 16 is the power, because it's the second column is power 1, yes, plus 9 multiplied by, yes, plus 6, yes, yes, linear in 11, yes. Seven, right? Okay. You know the rules, right? Okay, you use my you use my just a moment. You put calculate it or you put use the calculator here. Now, first number is 6. 6 plus 6 plus 15 by 16. No. Okay. You continue. Okay. Okay. Something wrong here. It's not 10, but 16. Right? It's different. No formula. Yeah. This not 10, but 16. We change it. Right. This 16. Because everything is in 16. 16. 16. Yes. Now, the first number is 6. The first number, okay, I have you with 6. The second is 16 by 15 by 16, okay, you write it. 15 by 16 is 240, yeah, 240, yes. And the next one, 9, okay, 9 by 16 by 16, right? Equal 1,304. The next number is 6 by 16 by 16 by 16 equal 24,576. Now the last number, okay, 11 or 11 until 16 until 16 until 16. How many times? One more time. 4 times. Equal 270,386. Now the last number, 7 by 16. How many times? 5 times. 1, 2, 3, 4, 5 times. 7 million. 0. you add up all the numbers. Now you add up all the numbers. Now, okay? Use the calculator here. First, 240 plus 2304. Yes. Yes. Now, guess. You guess? The last two numbers are the same? No. No. Why? Because you find some wrong number. Do it again. Do it again. 6 plus 212 plus 2304 04. Wow, still something wrong. You take it? Okay. The most important is you know how to calculate, translate it. Now also they come back to this in your pen and paper. Who still don't understand how to convert from hexagonal to decimal? Raise your hand. No, everyone know how to convert, right? Recalculate. Wow, something wrong. Something wrong in my slide. Which one? The first hand, right? First hand. Okay, you could discover, yeah, you know something wrong in my slide. It means that you could understand it. Now is that a break? And who still don't know how to convert, how the numbering system works. So you could do it by yourself. And after who understand well the numbering system, so you could take break, 10 minutes break. And I propose you stand up, walk outside, doing some exercise. It's better for your health. Another question why here. In this slide, we have lots of questions why. Now, the first why, who has the question why? The first question why? Yeah. There is a great chance, some students come to me and ask the question, why do we use the hexagon model? Why not 100? Why not 32? Why not 64? Why not 8? But we use 16. Who has the answer? Why don't we use the binary? Why don't computer use the decimal like us? But the computer use the hexagon, hexagon model. Who has the answer? Why? Now, I assume that you know all how to convert the two numbers, right? Two numbering systems, 10 and 16, or even in F or in any numbering system. But the question is why? Yes?
I think that because computer systems, there are 256 characters, so 16 squared is exactly that. So we have this because there are two units to represent a character.
Yeah. He said that in our computer system, there are 256 characters. So that's why people use the hexagonal system to encode the characters, right? And which is the egg and the chicken. Which one exists first? Chick or egg? Chicken or egg? Egg or chicken. It means that we have 256 characters and we have 1 byte of 8 bits. We all know that, or you may know that 1 byte equal 8 bit. Each bit, 1 bit, equals 0 or 1. It means that 1 byte to encode 2 values and 8 bits, and it's 256. That's his idea. Now we have 256 characters, and so that's why we have 8 bits. That's one way of thinking. And another way of thinking is we have 8 bits, so we have 256 values, different values. So because any situation, in any program, if we could ask the question, why is needed, we could understand the circumstances and we could understand. Now, that's here is why. In decimal, every day we use, 2,697,78. That's the numbering system we use every day. And in hexagonal, it's 002927 and 76. And actually, this actually stored inside our hard disk, stored in our RAM memory, and calculated in the CPU. It's all 0 and 1. Now, you could compare between the three numbering systems in decimal, in hexagonal, and in binary. This in decimal, hexagonal, in binary. Now, you could compare three numbering systems. And we once again ask about why binary. We could ask again, why binary? Who could answer why binary? Yes. We guess. So if our guess is reasonably correct, we could understand it.
I think binary exists because in computer there are only two states, and there is actually classroom or no electricity. So it's only that's how it is.
Who has another explanation of why we use binary, why we use hexagonal, why we use the two numbering system, in computer, or binary or hexagonal? Who has any idea? This is the reason why. Because I wanted you to think first. It's easy for me to tell why this is binary. But you think first.
I guess it's because of the digital signal.
Because our digital signal usually have a top and bottom, top for Z1 and bottom for 0. That is the reason, right? Yes. It's rather correct because actually everything will be implemented in our electrical system. So 1 means we have some voltage there. 0 means there's no voltage there. That's very correct in that way. Because anyway, we have to implement everything 0 and 1 by using electrical signals. But that's another aspect. Any question? Any explanation? Here and here. Because we know that all of our calculations, even in 0, 1, even in decimal, even in our hexagonal, everything will be implemented using electrical system. And in our computer, all of the calculations, very complex calculation. Every thing we transmit from this computer to another computer. every color on our screen, every number we get when we do some calculation is based on very, very basic mechanisms like this one. Our computer nowadays work everything here, do the calculation in 0 and 1. And for the two input signal, 0 and 1, we have four basic types of operators. For example, we add two numbers, 0 and 0. If the signal is 0 and 0, we have the output 0. 0 and 1, we have the output 1. 1 plus 1 becomes 10. You remember 1. 1 plus 0, remember 1, it becomes 0, 10. 1 plus 1, and remember 1, it becomes 11. 1 and remember 1, and so on. And because we know about the binary operators already, so you could do the calculation. 1. And in this case, we have to design an electrical chip or some way to do, if we have the signal, as he said, we have some voltage here and 0 voltage here. So we have to design this structure we call the AND or XOR gate, so that we have two outputs. That's the sum and C stand for what? C stand for just 0, 0 and sum and C. I forgot the abbreviation for the C factor. Who knows what is the C means? Yes?
Celsius.
Some kind of, remember, for example, just 1 0 becomes this 1 and remember 0. Yeah, like remember, but I forgot the name of the C. 1 1, yeah, becomes 0 and remember C, right? So, yeah, everything nowadays we talk about the computer is about 0 and 1 computer. Because in the future, and currently in some country, we hear about the quantum computer, right? And in quantum computer, people talk about the qubit. And here, for this computer nowadays, we're talking about the bit. There's some two values, 0 and 1. We store our data in 0 and 1. We do calculations in 0 and 1, and everything happens inside our computer in 0 and 1. And for the calculation, the most basic operator is to add two numbers. Two numbers in numbering system in binary is just 0 and 1. And the difficulty in designing such kind of architectures is to design the chip, design in our CPU, and even in some case, yeah, in mathematical processing unit. So that's why we have to use 0 and 1 is in binary numbering system. And here, this is the half adder. It's called the half adder, and this is the full adder. And in the full adder, we have two inputs, three inputs. Here, the half adder has two inputs, 0 and 1. And for the full adder, we have three inputs, A, B, and the remember number. Yeah, the remember And you see that with 2 inputs, yeah, it's rather simple, right? It uses the XOR gate, one XOR gate and one AND gate, yeah, to perform the half adder with 2 inputs and 2 outputs. And when we have 3 inputs and 2 outputs, you could see that the chip, the architecture or structure of the calculator of the adder is much more complicated. This is just for adding 2 bits to numbers, 0 and 1. Now let's imagine what happens if we have more input here. So how to design with multiple input, with multiple output for automatically do the calculation. And a million of calculations per second. This is what's happening inside our computer. Now, suppose that's just only for 1 bit calculations. Now, if we design a 4-bit calculator, 4-bit calculator adder, just for adder, we have input of 4 bits, A0, B0, A1, B1, A2, B2, and A3, B3, and we have to design these structures. But there's one problem here. If we wanted to speed up the calculation process, okay, we connect 4 bits adder together to build a 4-bit. So if we wanted to improve more, we use 16 bits. Improve more, we design 32 bits. Improve more, we design 64 bits. Now this job's only for 4 bits adder. Suppose that we use this architecture, this design. So what happens? Is that possible to build a 4-bit adder with this structure? Yes. Why? No. Why? No. Why? Yes. Why? So that's why, yeah, you understand why design the chip for fast and effective calculation is so difficult. With just only 1 bit full adder, you could see very logical gate. XOR and XOR OR, for example, OR and XOR gate. They connect together in a very intelligent, structure. They connect to each other, the signal of each other, and the drop of our calculation here, it is 0 and 1, 0 and 1, 0, 1. Very, in a high frequency, per second. We change the values of the input, very frequently in a second it comes, Our chip becomes, faster, stronger. And this is for 1 bit adder. And this 4-bit adder with this structure. Is there any problem for this structure? Yes. Who discovered? What is the problem with this structure? It takes two input, 1 bit. Calculate the output, the sum, and the remaining. Take the remaining and two inputs. It put at the sum here. Take the output and the remainder part. What problem with this architecture? Yes.
I think the problem is the remaining C4 is greater than 0, then the number will be not correct.
It means that, before we enter, we don't have a place to store the C4, and it causes some problem of overflow in our coding, in our program. Of course, this is the problem. The overflow is, in the programming methodology. I will demonstrate what is the overflow. We also saw it in our mechanical calculators, because we have one space for storing the result. But 7 add 3, it becomes 10, but we have only one space for storing our result, which becomes 0. 7 plus 3 becomes 0, because the C4 is overflow from our storage. But another problem is, in order to the second bit add 1 bit adder, we have to wait for the first bit to finish the calculation. After that, it means that this architecture of 4-bit adder works in a sequence order. Even if we have used 4 calculators, but it does not improve the speed, right? Because this adder, have to wait the output of the first adder to have this answer. It means that the calculation happens in a sequence order, and this is not effective. I would like to use this example to illustrate about the difficulty in designing the chip in our CPU. Yes. And everything is stored in our computer once again, just 0 and 1. Even we are given some structure of this data, we understand that, okay, this file is text, this file is bitmap, this file is docs, Microsoft Word docs document, this file is video, this file is music, this file is an HTML file. And to have the user or to have the computer work more efficient and more easier, people use the naming system with the extension. For example, for bitmap image, it uses the extension BMP. For JPEG format, we have JPG. Different video format, M4V, MP4, MPEG version 4. Sometimes we have the flash video. I don't know if we have Windows Media Video. For example, here we have Windows Media Video. It's also, some other people say that sometimes when I double click on one file, the Windows, the total commander will ask call some applications to open it. For example, in this case, I will instruct the total commander. There are several applications who process or who view this video files, including media player, flash, media player, and so on. Windows media player, for example, is this guy. So I put select this one and it opens it for me. And yes, it could open it. Of course, I put also, because I put, previously, so it remember how to use which application to open this file. And actually, here with total commander, we have the functionality called the associate with. Here, with this Windows Media Video files, it calls some application by this one. And we also would assign, we could select the program to open this one. And all of the values here are default values. For example, in different applications could be used for opening or viewing this one. This is for Windows Media View files, and that's for, I'm not sure. Yes, it's asked again. I could also use application or I can open it. For example, I'm not sure this applications. Yes. Yeah, something like that. And actually, there are not, for the file extension, a lot of file extensions used for different file format. And of course, you also see that. This open with Microsoft Paint, but if we view the data here, all are in hexagonal, and we know that the program we did the signal for 2 and for the Y signals and use. The program knows that check first whether or not it's a bitmap file, because if not, I could change. Okay, so I change the text file here, becomes BMP. Now, I change it to BMP. So, I could open it? No. Because it's not the BMP files. Because now, how about the data citation? We could see that, and this for data files. I go to the Windows file, some program, system 32, and the files CMD. Besides, it has the EXE means executable. I still verify encoding in hexagonal, always just for binary actually, but if we could see in text, it has some signature M Z. You could see that it might, every executable file has every executable file have MZ characters, and sometimes it has some text. Is that this program cannot be run in this operating system mode, but it runs on Windows, and for some application would only run on 32 operating system. Some application just run on 64 operating system. And here we also see that and see every and this for DLL MZ. It has a signature. And in order to understand the real meaning in your files, you have to read the values and consult the structure of the files of the data files. You will see that, yeah. Programs, dynamic link library, text files, bitmap file, PowerPoint files, here, PowerPoint static again. Yes. Yeah. And for PDF files also, it has some signature. Yeah. This is textual format. Version, PDF files, and the version of the program that create this PDF files. So in short, for data representation, our data, our calculation, everything here is in 0 and 1. And in order to know that this file is a text, image, or a program, we have to understand the meaning of the data. The meaning of data means the information. Now, about the data presentations, do you have any question? Any question? One people ask question, and 100 people know the answer. If you don't ask me, I will ask you.
Okay.
I ask you. Yes.
So why don't we use something more than hex on the 32 bit something or 64 or even 256?
The question is that why don't we use another numbering system, larger, not but just only 0 and 1, or hexagonal? Double, yes, double than hash. Yeah. His question is that I take this example. I usually, yeah. Why this total commander provides us in binary, in hexagonal, but not in a 32 numbering system or 64 numbering system, right? But in hexagonal. Who knows the answer? Why don't we use another numbering system? I think that the unit used in our computer is byte, right? 1 byte is 8 bit. It means that 1 byte we would store 256 different values. And in this case, we have FF here is just only for 4 bits, and FF here, F here, 1 characters for 4 bits because we have 8 bits. We use 2 characters. We have 2 parts, the lower bits and higher bits. So we need only 2 characters, and each character is 16 numbering system. So that's why every byte here we use 2 characters to describe. It means that if we use more 32, for example, that number, we just use only one character, right? we shorten the representation of that number. But we need more characters. Not only stop at F, but we have to extend 16 more. So it's more difficult to remember. We usually use a 10th numbering system. So we extend it to F 15. So it's easier for us to remember. It's neat, but here, yes, this one. If we use simpler numbering system, smaller, we have a longer sequences of representing the same number. If we use the decimal, which is, we use hexagonal, it shorten this representation. If we increase hexagonal, we shorten more the representation, but we need more characters to represent the number. And people calculated in information theory, 8-bit is optimal for storing the information. 8-bit is optimal for calculation, design the calculation inside the computer. So according to the information theory, 8-bit is optimal. Of course, in information science, you will learn more about why people use the 8-bit. Another question, very interesting question. Why 8 bits, not 10 bits, 32 bits? More appropriate. You know that now for qubit, not only 0 and 1, but we use qubit with very large number of states. We would boost the computational time, but it's very difficult to design. It's very, very difficult to design the computational structure. Because here we have very simple, as we said, just have the voltage or not have any voltage here. So the design of the chip is here, the structure of the chip here. But still very complicated. If we increase on the step, not 0 and 1, but infinite value. It's very difficult to have the correct calculation output. And next question, please. Okay, so you have a lot of things to learn more about the visualization and how to design a chip and so on. Now we move to another topic. That's about the file system. Actually, the file system, is used to manage or to store our data, our information. Usually, we have computer inside a computer. We have server disk. Inside each disk, we have server directories. And inside each directory, we have subdirectory, and in subdirectory, we have our data, our files. I demonstrate, you use 3 file system. The first one here, my PC, inside the Windows operating system, we have 3 panels. How do we see? Yes. see in very detailed inverse selection. So, yeah, the structure here in every file system, here driver C, inside driver C, you have program files or user, different user in different my laptop, in different folders. This the file system, usually file system of the Windows operating system. And in the Linux, we have also that file system. Yeah, my folders, different user, and different group of user, IoT, Institute of Information Technology, Institute of Physics, maybe BOOST, Graduate University of Science and Technology, IMEC, Vietnam Satellite Center, for example, group of user, data user, and in system we have different modules. In home we have different. Yes, I could not access that. The directory from. This is another file system. In my Google Drive, have such kind of structure. Yes, organized also in different folders. Yeah, something like that. And your homework is to explore. Your homework is to explore the file structure in your mobile phone. Could you draw the file structure of your mobile phone? Yes. Now, it's your task. Now explore how many folders are there in your mobile phones. How to explore it?
Google Photo folder.
Okay, so I think everybody phone in this auditorium have the same with my phone, so we will join the program. If you use iPhone, I don't know if you use Android as a file, your file. Please?
Your files.
Yeah, your file.
My files.
Yeah, my file.
Yes.
Okay, and then you can see over here after mobile phone
Yes.
with memories and my SD card, memory card. So to explore the files, I click on, I choose my mobile phone card, mobile phone memories, and then I can explore. There are so many of files like the DCMI, the download on the internet or the movie, music, and also the picture.
Yes. Also, thank you. On my mobile phones, the operating system already created some folders for me. For example, the download, the image, the video, the audio is in logical folders or physical folders. Could you distinguish between the logical folders and the physical folders? Logical folders and physical folders. Because it concerning, in some operating system they use alias, not exactly. For example, here I demonstrate here. Yeah, this structure could be viewed in a logical or physical views. I demonstrate here. I use the File Explorer, and in the File Explorer, it has the downloads. It has the My Documents. Where's My Documents? Home is about this PC. It has documents, and this the documents. This is logical folder or physical folder. This physical folders. This is physical folders. Sometimes we use different applications, and where exactly is the folder documents, and the documents folder here is the same for different user in my computer or not? No, right? This is for each user, and the documents here are okay. I find the documents folder anywhere where it's some property and its user my laptop. This location means exactly that's in physical folders. Now I search user my laptop documents here. User my laptop. This exactly. Then and this now we could compare the content. We could see that now my music in here. Right? No music. No my pictures. No my videos in the File Explorer view. So, because this category, because when you do some programming, you see the logical folders, but you write some applications, write some code to open that folder, but your program could not find that folders. Sometimes, in some cases, we need to use exactly the physical folders. We specify exactly it's either C driver, users folder, my laptop and documents. Careful with the logical and physical folders. And in general, every operating system in every computer, our data organized in the file structure, in the tree structure like this. And thus we provide all logical or physical view, but actually it's stored in our hard disk. In the case of hard disk, so the hard disk organized in the sector in the track. Each track divided into in different sector, and each sector is divided into 4 sectors in this case. And this for your understanding, and in some cases your data your hard disk is broken. Sometimes it's broke just only the information of your hard disk, but your data is still there. So in order to recover your data, it's still possible, even if your computer would not read the whole hard disk. And this is for your homework. Understand and use correctly the bitmap and vector image. For your practice, the next two practice, you practice with creating the documents with Microsoft Word, creating stuff, and you compare with the content of Word, the differences between the Word documents and the PDF file formats. You learn about the file allocation table with NTFS file system, compare and use the local and cloud storage. All of the homework, all of the tasks is designed for you, for your future work, for your future study, not only for passing this lecture, not only passing this lecture. And in the practice, you will use Microsoft Word and to create or open office to create documents. And every people could write the document, but write the document in a good way. For example, using the right image format for a better quality, ensure the quality of the document. It's not easy. And this is the end of my lecture today. We finished early because now it's more 6 p.m. and I think that you all hungry, tired, and the traffic is jammed. Know about that. If you have any questions, so I not recommend you ask me today right now. But if you have any questions, email me or ask me in the next lecture. Thank you very much.
Trong trường này nó phải chơi A9 cực.
Trường này là cái tổ A9 đúng không?
Tôi trường này là cái tổ A9 ấy.
Câu ơi gửi này nhá.
Ok.
Không được thôi.
Ghi mỗi cái tên thôi.
Ở đây. Nếu vãi, account này xinh thế.
Hả?
Account này xinh thế.
Gì cơ?
Account này xinh thế.
Thì chơi từ đầu. Đây này, chơi từ ngày 4 tháng 2, 2020. Đây là nó